Welcome to Brain Vision.
Okay, so in this problem, we have an instrument hanging from a wire inside of a spaceship. So if it's being held by a wire, then it's being supported by a tension force in the upward direction, and at some point the spaceship is going to accelerate upward. So therefore, we know that the tension force is going to have to be greater than the weight of the spaceship. So in equation form, that means that the tension force has to be greater than the weight. So that's what part A is asking for. And just to record a little bit of information that we'll need for part B, this instrument has a mass of 6.50 kilograms. We begin at rest before takeoff, so the initial velocity is equal to 0. And in this experiment, we climb to a height of 276 meters over the course of 15 seconds. So that is our time interval. So now we can begin part B, where we calculate what the tension force on this rope must be. So let's apply Newton's second law in the vertical direction to this wire. So the net force, sum of the forces, is tension minus weight. So in other words, we can isolate and solve for tension by collecting terms together and getting mass times acceleration plus gravity. But we don't know what the acceleration is yet. So let's do a little detour in kinematics in order to solve for the acceleration. So let's use this kinematics equation, and then we know that we're beginning at rest, so the initial velocity is equal to 0. So now we can turn around and back out the acceleration from here, so 2 delta y over delta t squared. And plug in numbers. So we have 276, and down here we have 15 seconds. So we've now solved for the acceleration, which is 2.45 meters per square second. So now we can go ahead and solve for that tension force. So remember the tension from all the way up there. We can plug in numbers and do T is equal to the mass, which we said was 6.50, multiplied by acceleration plus the acceleration due to gravity, 9.81 meters per square second, and get a tension of 79.7 newtons.